I am actually excited for today's lesson, and not because it's math, but because I decided it was Lino's turn, and there's so many pictures of him. Yes! This is Average Rates of Change, Unit 2, Lesson 9. So average rates of change can be shortened to be called just the rate of change, okay? When the function is a constant linear function or a straight line, okay? To find the rate of change, divide the difference in the output values by the change in the input values given an interval. If that doesn't make sense, don't worry. We have a formula. It will be fine. And oh, I'm smiling because of something. Okay, average rate of change formula. This is important. This should be in your notes. We're going to use it constantly today. So the function of b minus the function of a divided by b minus a given the interval ab. And you're going to be given the interval throughout the whole thing, so don't worry about that either. It can be used with a function given by a table, a graph, or an equation. So if you have any of that information, you can do this. And it can be negative, positive, zero, or undefined. Okay? That will make more sense as we get further in. Don't worry about it. Here's example 1. Find the average rate of change over the interval -4, 3, given the function table for f of x is equal to 2x squared plus 3x minus 7. We'll do this together. Don't worry about it. It's going to be okay. We got this. So first identify the 2 points that correspond to the given interval. So it's saying -4, which is right here on x, and 3. So I'm not really sure where we're going to find that point. Hopefully it will help us. So we have -4 and 13. Oh, I guess this 3 is just another x. So we have 3 and 20. These are the 2 points. So we're dealing from, let me pull up my tools. We're dealing from this point to this point, okay? That was easy enough. Substitute the corresponding values into the average rate of change formula. That's this formula right here. So let's see. Hopefully it will give us some more detail than that. Nope, it doesn't. Okay, it's the function of a. So 20 is the function, and the function of a is 13. I believe this is all we have to do. I hope so. And then b minus a. So 3 minus, and when we minus a negative, it becomes a plus, minus -4. Okay. 20 minus 13 is 7. 3 plus 4 is 7. So our average rate of change for this interval is 1. I did it. Oh my gosh, I overthought it and made it more complicated than it had to be at first, but it's not that hard. Hopefully this won't be a bad lesson. Estimate the average rate of change over the interval -1 and 5, given the graph of g of x is equal to the cube root of 3x minus 6. Okay, here he is laughing at me, as he should be, because I'm messing everything up. That's what I do. I'm pretty good at that. Ignore all of this garbage that I just did. I forgot that we're doing an example and that it's going to walk us through it. So first it says identify and approximate the 2 points at the given interval. So if we're approximating at -1, we have -2. So our first point should be -1, -2 if we're approximating. And our second point is at x equals 5, and we're going to say y equals 2. Because we're approximating. Now, why didn't it tell us that we were going to approximate? Because the math book is stinky, stinky poo-poo. Okay. Oh my gosh, I made a simple mistake here too. This is a -1, which means this is a plus, which means this is a 6, which means this is 2/3. Oh my goodness, guys. Wow, I'm doing really great today. Okay, let's just move on. Maybe if I pay attention. Here's example 3. Find the average rate of change for f of x is equal to 2 raised to the power of x. Change over the interval -2 and 2. So evaluate for the 2 interval endpoints. So we're going to substitute -2 into the formula because we don't have a bunch of information. We have only this. We don't have a graph. So we're going to say f of -2, okay, because that's our first point right here, is equal to 2 raised to the power of -2. Now, if you remember our exponent rules, if we have a negative exponent, we need to change it into a fraction. So it becomes 1 over 2 raised to a positive 2, which then becomes 1 over 4. Okay, so our first one is 1/4, and then we're going to substitute this second number, 2, into the formula. So we have f of 2 is equal to 2 squared, which is equal to 4. So our first rate of change is 1/4. Our second rate of change is 4. That's for the two endpoints, okay? So the first point is going to be -2 and 1/4 because we found the y endpoint. We were solving for y. And the second one is going to be +2 and 4. Okay, now we have our 2 points. So we're going to plug it into this formula to solve. I made Lino angry. I'm going to go figure out what I did wrong. Okay, I see what I did wrong. I simply put the numbers in the wrong spot. Let's try this again. So f of b is 4 minus f of a is 1/4. I just put the numbers in the wrong place. 2, which is b, minus a is minus a negative, is 2, which equals, this gives us 3.75 divided by 4. Okay, now let's pull out our calculator and we'll go 3.75 divided by 4 gives us, you know, the horrible 0.9375, which makes more sense with it being 15/16. Sure, we're going to believe you on that because I'm not going to bother figuring out how to make my calculator change that into a fraction. You know what? I can prove it. I'm going to just go ahead and do 15 divided by 16. And look at that, it's 0.9375. So we got it right. Cha-ching, we can do this correctly. This one's all you. Don't be stupid like me and just put stuff in where it belongs and you'll be fine. Question number 1, what are the values for f of b and f of a when finding the rate of change over the interval -3, 4, given the function f of x is equal to 4x squared plus 3x minus 2? Okay, so here's your formula right here. Pause the video, go and do it, come back. Okay, the first thing we need to do is get both of our coordinate points. We don't have a graph, so we can't just go to the graph. So we're going to take our formula right here, and we're going to substitute the information we have in it. These are both x coordinates. So we're going to say f of -3 is equal to 4 times -3 squared plus 3 times -3, all these 3's, minus 2, and we're going to continue on. That's equal to, let's do the exponents first, -3 times -3 is +9. So we end up with 4 times 9. +3 times -3 is -9 minus 2. Continue simplifying. 4 times 9 is 36. -9 and -2 is -11. 36 minus 11 is 25. So our first coordinate point is going to be -3, 25. Write small. We can do this. Oh my gosh, it's legible. Okay, so let's find our second coordinate point. Erase, 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 erase with all the power I have. Okay, the next one is f of okay, let's try that again. F and x is going to be equal to 4 because that's our second point right here. Okay, so we have 4 times 4 squared plus 3. Oh, that's a beautiful 3 times 4 minus 2. 4 squared is 16. Holga is singing to Dad Bob. 3 times 4 is 12, minus 2. 4 times 16, we are totally getting my calculator out for because I'm not doing that, is 64. And yes, I probably should have known that, but you know, I don't math. So plus 10, which means in the end it's 74. So our second point is going to be 4 and 74. Okay, now we have those 2 points. So I took it farther than we had to because it just wants to know what the values for f of b and f of a are. So those values, f of b is 74, f of a is 25. I kept going. Ha ha ha, watch me work harder rather than smarter. Let's see if I can be smart enough to stop and not go farther than I have to on this one. What are the values for a and b when finding the rate of change over the interval negative 3, 4 given the function f of x is equal to 4x squared plus 3x minus 2? This is your turn. Pause it, go do it, come back. Okay, so we only need to find the values for a and b, so I don't need to go all the way through it. But we're going to take this and plug it in to our formula. And, oh, actually, we don't need to. This is really easy. The values for a is right there. And wait, let me think. Let me think, make sure I'm not leading you astray. Yeah, these should be the values for a and b. It should be negative 3 and 4. Oh, I'm so good. I didn't screw you up. Watch me go. All right, this is question 3, all you. What is the average rate of change over the interval negative 3, 4 given the function f of x is equal to 4x squared plus 3x minus 2? This time it wants you to go all the way to the end and find the average rate of change. Pause the video, go do it, come back. Okay, first we need to find our coordinate points. So we're going to plug these x values into this formula. So our first one is f of negative 3. That's our first x value. Is equal to 4 times negative 3 squared plus 3. Ooh, come on, we can do a 3. There we go. 3 times negative 3 minus 2, and that's equal to negative 3 squared is positive 9, so that becomes 4 times 9. 3 times negative 3 is negative 9, and we still have our negative 2. 4 times 9 is 36. Negative 9 and negative 2 is negative 11, so our y coordinate for this one is going to be 25. I feel like we already did this one, but we'll just roll with it. Our first coordinate point is negative 3, 25. Okay. I wonder if this is the one that I went all the way through earlier, and I'm just doing it again for no reason. All right. Let's do f of our second x value, which is 4. So we have f of 4 is equal to 4 times 4 squared plus 3 times 4 minus 2. 4 squared is 16, so we have, this is the same one, 16 squared plus 12 minus 2 becomes 4 times 16 is 64. 12 minus 2 is 10. So this becomes 74. Look at me. I look like I know what I'm doing with math, and all I do is remember the problem I did 2 seconds ago. We'll pretend that I'm a math genius. So there's our second coordinate point. Oh my goodness. And here is, oh, I just erased the wrong thing. Oh, Holga is losing her mind at nothing because that's what she does best. So we're going to erase all this garbage now. And now we just need to make sure I put these in the right order. So we have f of b, which is 74, minus f of a, which is 25, over b, which is 4, minus a, which becomes a positive 3, 74 minus 25. Let's go back and look because I don't even want to dig out my calculator. 74 minus 5, that's not the right problem. That's not the right problem. See how much time I'm saving. 74 minus 25 is 49. Okay. 74 minus 25 is 49. 4 plus 3. I know. I don't have to look. It's 7. And that becomes... Oh, this is 7. So how did I get negative 7 last time? I'm so smart. Don't ask me, okay? I'm just doing the best that I can with my stupidity. Okay, here's question 4. That's all you. Find the average rate of change over the interval negative 6, 2, given the function table for f of x is equal to 2x squared plus x minus 2. So here's the table. It gives us all of this information already, and it wants to know which one of these is the correct answer. So we're dealing with this coordinate point because it tells us that right there at 6, 2, at negative 6, and we're dealing with this coordinate point. So it wants the average rate of change over the whole thing. Moose is now nudging me in the head. I'm doing really, really, really great. Okay, so we need f of b, which is 64, minus f of a, which is, oh my goodness, look, I'm messing it up already, and I'm going to change to black because I don't like the way this looks. So we have f of b is 8, minus f of a, which is 64, over b, which is 2, minus a negative 6, which makes it a positive 6. I don't want to think, so we're going to get a calculator. 8 minus 64 is negative 56 over 8. And again, I did lose. I didn't learn all of my times tables, so 56 divided by 8 is 7. So this one should be negative 7, and that's not an option, so we're going to say positive 7. You know, the puppy is trying to knock things down on my head and kill me, so we're just going to blame that for all of my major disasters that are going on. This is question 1. This is still you. Just work on it. This isn't the end. They just moved on to something else. Estimate the average rate of change over the interval negative 5, 1, given the graph of p of x is equal to 2 raised to the power of x minus 3. So this is all you. Pause it. Go do it. First thing you need to do is get your 2 coordinate points. So at negative 5, our y is about negative 3. It's not exact because remember this horizontal asymptote never levels out completely, never touches that point. So our first point is going to be about, that's why it says estimate, negative 5, negative 3. I don't like this red on the orange background. And the second one is when x equals 1, it looks like y equals about negative 1. So we have 1, negative 1. Okay, let's see what we can do here. We need our formula. Oh, good. I deserve the bombastic side eye for this because once again, my problem is that I'm not putting things in their correct places. And why am I not doing that? Because my dogs are losing their ever-loving minds over nothing. Okay, let's focus again. F of b is right here. It's negative 1. F of a is negative 3. Okay. B is 1. A is 5. Okay. So that's going to give us, I swear if these dogs don't stop, negative 1 plus 3 is 2. 1 plus 5 is 6, which then gives us 1/3, which is the correct answer. If you put the numbers where they're supposed to go, it's not so hard. Okay, here's question number 2. This one's all you. Find the average rate of change over the interval negative 4, 3, given the piecewise linear function table. Okay, so this time we have a table instead of a graph. So here's our first set of coordinates. Here's the coordinates at negative 4, and here's the coordinates at 3. Those are the 2 coordinates we're going to use. I wasn't supposed to tell you that. I was supposed to tell you to pause it. Pause it! Go do it! Okay, here is our first coordinate. Here is our second coordinate. Come on, Bob, we can do this. F of b is negative 3. F of a is 1. B is 3. A is negative 4, but it becomes positive because we're subtracting. Negative 3 minus 1 is negative 4. 3 plus 4 is 7. So your average rate of change should be negative 4/7. Hallelujah, I got it right. Okay, this is at the very end of the lesson, so just write your answers down, and then when you get there, you can enter them. Practice question number 1. Use the formula f of b minus f of a divided by b minus a to calculate the average rate of change over the interval negative 2, 0, given the function table For f of x is equal to x squared plus 6x plus 8, express your answer as an integer. Pause the video, solve it, come back. All right, so first we need to find our coordinate points. We're dealing with -2, so we're right here. And 0, so we're right here. Those are the 2 points we're dealing with. This doesn't matter for this. This is just extra fluff. Don't get confused by it. Don't get distracted the way I've done this entire lesson. F of b is 8. Minus f of a is 0. B is 0. A is -3, which becomes a positive. That becomes 8 over 3. So our rate of change should be 8/3. Okay. Here's practice question number 2. If I put all the numbers in the right place, make sure I did, because you never know with me. Practice question number 2. Calculate the average rate of change over the interval -1, 1 using the given graph of the function. Pause the video, solve it, come back. Okay, the first thing we need to do is find both our coordinate points. So when x is -1, our coordinate point is right there. Okay, it even made a mark for us, which is -1 and 9. So our first coordinate point is -1, -9. Thank you, math book, for using your brain and helping us. Okay, when x is +1, our coordinate is 1 and 3. Thank you, math book, for not expecting us to read your mind. Okay, let's plug this in. F of b is 3 minus f of a is -9. B is 1. A is -1. 9 plus 3 is 12. 1 plus 1 is 2, which means our average rate of change is 6. Boom! Okay, quick check question. I'm not going to give you the answer for this one. This is yours to figure out. Calculate the average rate of change over the interval -2, 4, given the function table for f of x is equal to -x squared plus 12. And then it gives you options to choose from. Now I will tell you how to do this. I'm not going to give you the answer. But first you need to find your coordinate points, okay, based on the interval. And then you need to use this formula based on the coordinate points you found to figure out which answer is correct. Quick check question number 2 says calculate the average rate of change over the interval 3, 4 of the given graph of the function. So the first thing you need to do is find your coordinate points based on this interval using the graph. Then you're going to take those coordinate points, plug them into this formula, and figure out which of these answers is correct. You can do better than me. I know you can. I believe in you. Okay, second half of the lesson, linear functions. This is important, okay? This is going to help it simplify. Don't overcomplicate things. The rate of change is the slope of the function. We've been dealing with slope a whole bunch. When the line is straight, it's just rise over run, okay? Now when the line's curved and it's doing silly, weird things like this, we can still have trends, okay? They can trend positive, they can trend negative, they can be 0, or they can be undefined, okay? This should be in your notes. But when the line is straight, it's simply rise over run. This is going to come in, okay? When the line's not straight, that's when we need to use our magical little formula like we've been doing. But when the line is straight, just let it be easy. Breathe, let it be easy. Here's example 1. The graph of the function f of x is equal to 3x squared minus 6x plus 6 is shown in the image. I see no image. Way to go, Mom Bob. Describe the function graph by finding the average rate of change of the function over these intervals. Let me go see if I can find that picture. He's going, really? You just didn't put the graph in there. I know I didn't. Now I had to make the graph really little, so if I have to blow it up so that we can find our points, we will do that. But they want us to do it for all 4 of these. So we're going to work through this together, okay? So the first one we need to find is for 0 and 1. So when x equals 0, then y is going to be at 6. So our points here are going to be 0 and 6. And when x equals 1, y is going to be 3. Okay? X is 1, y is 3. Let's go ahead and use our lovely little formula right here to find the rate of change for this. So f of b is 3 minus f of a, which is 6. And we have b, which is 1, minus 0. So we have negative 3 over 1. So this one is just negative 3. Okay. We will do all of these. If you don't feel like you need that, you can go ahead and skip to the next slide. Just fast forward until you hit it. Okay, so when x is 0, we know that y is still negative 6. When x is 2, y looks like it's also 6. Okay, so we're going to go to 6. Okay, and this one is 0, 6. So let's see for this interval what the average rate of change is. F of b is 6, f of a is 6, b is 2, a is 0. That's going to give us 0 over 2, which ends up being just 0, because 0 divided by anything is 0. Okay, let's do the next one. We have when x equals 1, we have y equaling 3. And when x equals 2, y equals 6. So this is our next interval. Okay, so we have 6 minus 3 over 2 minus 1, which gives us 3 over 1. So this one is just 3, positive 3, plain 3. Figured out where I wrote wrong. I'm just doing math wrong because that's me. I did 12 minus 12, and it's 12 plus 6, which gives us 24 plus 6, which is 30, which is what we're supposed to have. So this should not be 6. That should be 30 right there. 30. And now let's plug all this information into our formula. We have 6 minus 30 over 2 minus negative 2, which gives us negative 24 divided by 4, which would give us our negative 6. See, if I just mathed, then everything would be okay. This demonstrates that a function can have several different average rates of change and more than one type of rate of change. Okay, so over the course of this, depending on which interval you're looking at, you can have very different numbers. So here's a check-in. Describe a function with a positive average rate of change on the interval AB. And what that means is a function with a positive average rate of change on the interval. That means in general it's going up, regardless of how it looks. It could be a straight line. It could be something wonky. It could be just a slope like that. It could be, whatever. Generally it's trending up. This one is not. That one's trending down. But you know me, I'm good. A function with a positive average rate of change on the interval AB has values of a and b such that b is greater than a. This results in the positive average rate of change according to the formula. Okay. Here's another check-in. When will a function have an average rate of change of 0 on the interval AB? And that's when a equals b. So if they end up equaling the same number, there's not a change. It's just a flat line. Hey, look at that. I can't even draw straight. There, that's a little bit better. And look, I switched those slides because I'm so good. Here's example number 2. The graph of the function f of x is equal to the cube root of x is shown in the image. Describe the function graph by the average rate of change of the function over these intervals. So this one has a generally positive slope. Okay, a generally positive rate of change. The whole time it's generally moving up. It's not asking that, but I wanted to show you that because I'm confusing. So let's go ahead and look at these intervals and figure out what it's saying, what the number is going to be for each of them. We need the graph to get our numbers for our intervals. So when x equals -1, y equals 1. So we have -1. Oh, sorry. Ha 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 ha. Look at me not mathing again. When x is -1, y is -1. That's this point down here. Derp. And when x is 0, y is 0. So there's our first coordinate points. When x is -1, we already know that y is -1. When x is 1, then y is 1. That's the first point I drew. When x is 0, y is 0. We already know that. When x is 1, y is 1. We already know that. When x is 0, y is 0. We already know that. And when x is 8, we can't see it on here, so we're going to have to plug it into our formula. When we have x being equal to 8, that means that the cube root of 8, so our y value is going to be 2. Okay, so we have 8 and 2. Okay, so now we're going to come over here and we are going to use our coordinate points, plug it into here, and find all of our information. So our first set of coordinate points is -1, -1, and 0, 0. Okay, I'm not going to do all of them this time. If you would like a video seeing all of them, come and put a comment saying you want to see all of the steps, for example 2 on the peach colored slide. Okay, but what you're going to do is you'll take f of b, which is 0, and subtract f of a, which is 1, and then take b, which is 0, and subtract a, which is 1, which ends up being 1 over 1, which ends up being 1. Okay, you're going to do that for all of these, and these are the rates of change you're going to end up with is 1, 1, 1, and it makes the point on this one when you go, oh yeah, the rate of change is steady this whole time. Look at this. It's not steady. It's not a straight line. That's super straight, but you get my meaning. It doesn't just... That was my second try. I'm doing so good. It's not just a straight line. It obviously has a different rate of change. So keep going, because the last one, it has a rate of change of 1/4. Okay? That's obviously not a steady rate of change through the whole thing. Okay, this is a little interactive that they have in the lesson, and we are going to be able to click and drag these around to make them match the different things. We are dealing with all straight lines here, so we don't need to do any math, okay? Because we know rise over run, we can do slope. Match the description of the average rate of change to the corresponding part of the graph. So let's look at A. This is all doing average rate of change is also slope. So rise is down 2 and over 1. So the slope for A is -2. So we're just going to move this one right there, okay? For B, we're going up 2 and over 1, so it's +2, okay? Don't make this harder than it has to be. For C, there is no rate of change, so it's 0, which means D has to go there. Let's make sure it's -1. Well, it's going down, so that's obvious. Down 1 over 1, that's -1, okay? Here's question 1 that is all you. Consider the following function table. Describe the average rate of change on each different interval. Okay. Now the book uses the intervals of -1 and 0, -1 and 2, -1 and 3, 0 and 2, 0 and 3, and 2, 3. Oh, and I have no idea why, and I get it now because I was looking at this as coordinate points. And it's not coordinate points. These are just all of the different intervals they want us to use. So the first thing you need to do is find coordinate points for each of these. And then plug it in and then solve. So pause it. Okay. So for our first one of -1 and 0, our coordinate points are going to be -1 and 11. Okay. And 0 is going to be 0 and 2. Okay. And this all ties to this one right here. So f of b is 2, f of a is 11, b is 0, a is 1, which means -9 over 1, which leaves us with just -9. Okay, so our first rate of change is going to be -9. Now, it's also going to ask us whether these things are increasing or decreasing. So because this is negative, that's going to mean that the slope is decreasing. Okay, so the answer for this one is decreasing and -9. All right, let's move on to the next one. Doop, 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 doop. Do you like my sound effects? I'm so good. I should work for like a professional company, right? So we have -1 and -2. So at -1, we have -1 and 11. And at 2, we have 2 and 10. That 11 is the best 11 I've ever written in my life. That 10 might be right up there with it too. So f of b is 10. F of a is 11. B is 2. A is 1. So we have negative 1 over 3, which is negative 1/3. So our next one is negative 1/3. Because it's negative, it's decreasing. Okay. Erase, 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 erase. Let's do the next one. We have negative 1. So again, we have negative 1 and 11. And then we have 3, which is 3 and 0. So we have 0 minus 11 over 3 minus a negative 1. So we have negative 11 over 4, which means our next number is negative 11/4. And because it's negative, it's going to be decreasing. Erase, 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 erase. Our next one is 1, 2, 3, 4. At 0, we have 0, 2. And at 2, we have 2 and 10. So now we have 10 minus 2 over 2 minus 0, which equals 8 over 2, which equals 4. So our next answer is positive 4. Because it's positive, that means that this rate of change is positive. It's increasing, increasing, increasing. Okay, next we have this one. So we have 0 and 2, and we have 3 and 0. So we have 0 minus 2 over 3 minus 0 equals negative 2/3. So our next rate of change is negative 2/3. I'm sorry, Lino, I had to draw on you. And that one is going to be decreasing because we're dealing with a negative slope, a negative rate of change. And our last one is 2 and 10. I'm pulling these numbers from this table over here based on these x values. And 3 and 0. So we have 0 minus 10 over 3 minus 2, which gives us negative 10 over 1, which gives us negative 10. So our last rate of change is negative 10, and that one will be decreasing. So we should have negative 9 decreasing right there, and negative 1/3 decreasing, negative 11/4 decreasing, 4 increasing, negative 2/3 decreasing, and negative 10 decreasing. Look at me go. Boom, I succeeded. Question 2. Consider the following graph of the function f of x is equal to the square root of x. Find the average rate of change on the intervals 0, 1, 1, 4, and 0, 4. Use the results to describe the function. Pause the video, go do it, come back. I cannot stand to delete that Lino. Oh, I just love a good black and white Lino, so we're going to move that. Okay, let's see. So our first interval, when x is 0, y is also 0. We can tell that from the graph. And when x is 1, y is also 1. So let's use our little formula down here. We have 1 minus 0 over 1 minus 0, which ends up being 1 over 1, which equals 1. And that is increasing because it's a positive number. 1 increasing. Okay, let's do 1 and 4. So when x equals 1, y also equals 1. When x equals 4, y equals 2. So that gives us 2 minus 1 over 4 minus 1, which gives us 1 over 3. So our next rate of increase is 1/3, and it is increasing. It's positive. And then our last one is 0 and 4. When x equals 0, y also equals 0. When x equals 4, y equals 2. So that gives us 2 minus 0 over 4 minus 0, which gives us 2 over 4, which then gives us 1/2. So our final rate of change is 1/2, and it is also increasing. So 1, 1/3, 1/2, all increasing. This function has a positive average rate of change for all intervals for which it is defined, and that's easy to see because you can see that it's increasing the whole time. The value of the average rate of change is smaller for for larger intervals and for intervals farther from x. So the rate of change decreases the further away you get from x. Okay, you can see that on the graph. This is at the end of the lesson. Practice question number 3. Tyreek is an engineer and needs to design a rocket for an experiment. If you haven't seen Sister Sister, you need to go watch it because there's a Tyreek on there, but he's not an engineer. He's a mechanic. He has calculated that the height of the rocket in feet with respect to time in seconds can be modeled by the function h of t is equal to 16t plus 160t. Find the average rate of change of the rocket over the interval 4, 5. We have no graph. We have no table. Pause it, go do it. Okay, we have no graph, we have no table, so first we have to find our points, which means we need to take our formula and plug in our x values, in this case t values, to find our y values. So when t is equal to 4, we're going to find our h value. We get 16 times 4 plus 160 times 4, and we are definitely pulling out our calculator for this one because I'm not playing that game. Clear. 16 times 4 is 64. I thought it might be, but I didn't trust myself. Plus 160 times 4. Clear, clear, clear. 160 times 4 is 640, which then gives us 407. Oh, 4. Okay, so our first coordinate point is 4, 704. That's crazy. That is nuts. Okay, let's figure it out. 4, 5. So when t equals 5, we're going to figure out what h equals. We have 16 times 5 plus 160 times 5. You know, my real handwriting is actually quite nice. I worked really hard on it when I was learning, and this just makes me laugh because I look like I don't even care. 16 times 5 is 80. Oh my gosh. Plus 160 times 5 is 800. Okay. So that's going to give us 880. So our second coordinate point is 5 and 880. Whoop. All right. Let's use our formula of the day and figure out the rate of change for this. So we have 880 minus 704 over 5 minus 4. I'm totally getting the calculator for that. I am not thinking that hard. We have 8, whoa, ho, 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 ho. We don't have 880. Now we have 880 minus 704 is 176 divided by 1, which is equal to 176. So the average rate of change for this is 176. Boom! Okay, practice question number 4. Describe the behavior of the function by determining over which interval the function has a negative average rate of change. Consider only intervals with consecutive endpoints shown on the graph. Okay, pause it, figure it out, come back. The only interval that has a negative rate of change is trending downward is from 2 to 3. So the answer is 2 and 3. I like that problem. I wish the quick check was like this, but they never do this on the quick check. They build up your confidence and then they totally screw you. Practice question number 5. Which option is the graph of a function which has a positive average rate of change on the interval -1/2 to 0? Pause it, figure it out, come back. So we're dealing from -1/2 to 0. This one's trending downward. Wrong answer. Okay, from -1/2 to 0. This one's also trending downward. Wrong answer. -1/2 to 0. Look at that. He's going upward. We like the little S-curve one. All right. Here are your quick check questions for the end. I will not give you the answers. Calculate the average rate of change over the interval 3, 4 of the given graph of the function. So first, use this interval to figure out your points on the graph, your 2 coordinate points, then plug the coordinate points into this formula, and then figure out which of these is the correct answer. Quick check question number 3. Describe the graph of f of x by selecting the correct statement. So look at this. You shouldn't have to do any math because they're all straight lines. So you need to look at the intervals and figure out if the rate of change is positive or negative or whatever. And pick the correct answer there. Quick check question 4. Given the graph of f of x, on which interval is the average rate of change the greatest? Okay, so you're going to look at this and you'll figure out when is the rate of change the greatest. And if that is confusing you, if that's giving you a little bit of a headache and being like, but I don't know, remember, the rate of change is the slope. Okay? So if we're looking at this, which interval has the greatest slope? That should make it a lot easier. Quick check question number 5. Use the average rate of change to describe the graph of f of x over the interval 1, 4. So figure out your interval, look at it, and decide which of these is correct using your lovely formula. Now, in case you didn't know, Lino is my bias. It deleted his picture right here, and it's a good one. I'm going to fix that. I don't know why it was spazzing out like that, but you need that picture. That picture is so wonderful. Yeah, so yeah, happy math, guys. Happy math. Happy Lino. Let's be real.